Hello everybody and welcome to part B. We're looking at page 19 of the workbook here, and this is another example of an integral that we're going to try to do using the integral table. So the integral of x squared sine of x. Okay, now this function doesn't really fit the form of the previous two examples that we had, and so we're going to have to look in a different place in our integral table. So let's look at the integral table and see if we can find a match that's promising. Okay, so if we kind of scroll down through our forms here, eventually you come to a page of so-called trigonometric forms. And I think under this list of formulas, we might very well find a match. Okay, so remember our function that we're integrating looked like x squared sine of x. Okay, I'm going to write that down just so we don't have to keep flipping back and forth. Do you see anything under this list of formulas that looks promising for us? Okay, if you look for a while, you might notice that formula 84 appears to be the best match here. Okay, it uses u's. Okay, we're using x's, but that's no problem. We can just write x's instead of u's. Notice that if we use formula 84 with n equals 2, we get exactly what we want. U squared sine of u, that's essentially what we're integrating. Okay, and so it tells us that our antiderivative is going to look like this. Okay, so I'm going to go back to the previous page and write down that antiderivative, keeping in mind that the value of n is 2 and we're using x's instead of u's. All right, let's do that. So this is going to turn into negative x squared cosine of x plus 2 times the integral of x cosine of x dx. Okay, I'm going to remind you where this came from. This came from formula 84 using n equals 2. Okay, I want to just sneak a peek back at that. Okay, so these n's that you saw here, n and n minus 1, this one became a 2 and this one became a 1, if you're wondering where those powers came from. Okay. So far, that's where we're at. And then the question is, are we done with this problem or is there more to do here? Okay, well, we're not done because there's still an integral left. Okay, we're not finished until we finish taking integrals. And so we need another integration formula to figure out what that integral is. Okay, so back to the table, we're trying to integrate x cosine of x. Can we find a match for that? Okay, well, notice that the formula right above it, that's a nice match for x cosine of x. Again, u cosine of u is just using a different variable, but formula 83 tells us that the integration formula is going to look like that, cosine u plus u sine u. We'll just take that and fill in an x where we see the u. Okay, so going back 2 times, and we'll write down that formula, cosine of x plus x sine of x. Okay, and I'm going to remind you where that came from. That was just formula 83. Okay, and now we are done because we've gotten rid of all the integrals. Let's just rewrite our answer one more time here. We can maybe take that 2 and distribute it through. Okay, and this illustrates the fact that it's okay to use more than one table formula in one problem. Sometimes you'll need to do that. Okay, and we'll see that in some of the future examples we do.